Today we're going to learn how to draw Lewis structures for polyatomic ions. So first, it's good to review what a polyatomic ion is. You can find your list of polyatomic ions on the back of your periodic table. And what it is it is an electrically charged group of two or more chemically bonded atoms that act as one unit. So what we need to make sure we do when we're drawing our Lewis structure is that we take our ionic charge into account. And this is because charge is due to the number of electrons. And because we draw in a Lewis structure the electrons, we need to take those into account. However, really besides that, taking the charge into account, these are going to be very, very similar to the Lewis structures that we drew before. So the first step is going to be to determine the total number of valence electrons in the ions. And then the new part is that we just have to add the charge at the end. We're going to follow the same rules for drawing the molecules that we did before. And then we want to just make sure that our total number of valence electrons matches. And if they don't, then that's whenever you can add or remove some electrons in order to give them a full octet. Remember, most things want 8 electrons. The exception would be hydrogen because it follows the duet rule, so it only needs 2. And also boron and beryllium that can be electron deficient. And then another new step is that we're going to put the Lewis structure in brackets with the charge as a superscript. And this is just to let everyone know who's looking at the Lewis structure that it is the charge of an ion. So before we even get into the polyatomic ions, let's just do the ion chloride. So if we look at our periodic table, chlorine is a halogen. So chlorine has 7 valence electrons. However, because it has a charge of -1, this means it has an extra electron. Because electrons are negatively charged, if it has a negative charge, that means there's an extra one. And if something had a positive charge, that means you would subtract 1. So here, because chlorine has 7 and it has a charge of -1, we have 1 extra electron. So we're going to have 8 electrons to work with. So if we just draw the symbol Cl, and then we would have 8 electrons, which would then be a full octet for chlorine. And now our new step is that we're going to put the Lewis structure in brackets, and we are going to write the charge as a superscript. And that's it. Okay, that one seemed pretty easy. Let's try a polyatomic ion. Let's try hydroxide. So O has 6 valence electrons. Hydrogen has 1 valence electron. And now we need to take the charge of -1 into account. So because it's -1, that means we have 1 extra, which then means 6 plus 1 plus 1. We have 8 electrons to work with. So we're going to draw our bare bone structure. So we're going to draw O bonded to H. In drawing that, I just used 2 electrons. So I have 6 electrons left. And hydrogen doesn't need any more electrons because it only needs the 2. But oxygen still needs 2, 4, 6 because it already has 2 in that bond. But that's how many we have left. So we can just go ahead and add those 6. So now we don't have any electrons left, but everything has an octet that needs it. And so this is done, except for step number 4. We need to put the structure in brackets and write the charge as a superscript. It's that easy. In fact, I think ions are actually easier than non-ions. Okay, so far we did two ions that had a negative charge. Let's do ammonium, which is a positive charge. So nitrogen has 5 valence electrons. Hydrogen has 1, but there are 4 hydrogens, so that would give us 4 more. And in this case, it has a charge of positive 1. So that means that ammonium is missing 1 electron. So we would subtract 1, and 5 plus 4 is 9, minus 1 is 8. So we have 8 electrons to work with. So we'll draw our bare bones structure. So we'll draw nitrogen bonded to hydrogen. We have 4 hydrogens. So nitrogen here has 4 bonds. So in drawing those 4 bonds, I used 8 electrons, so I don't have any electrons left. So let's hope that this works. And if you look, nitrogen's got a full octet, so it's happy. Hydrogen is forming 1 bond, which makes it happy. So we are done, except for brackets and the charge, which in this case is 1 plus. Numbers 1, 2, and 3 all had 8 electrons total. Let's try one that's a little bit different. So let's try number 4. So carbon, that has 4 valence electrons. There's 3 hydrogens, so that'd be plus 3. Nitrogen has 5, plus 3 more for the next 3 hydrogens. And then it has a positive 1 charge, which means we're going to subtract 1. So 4 plus 3 is 7, plus 5 is 12, plus 3 is 15, minus 1. We have 14 electrons this time to work with. So let's draw this. So we have carbon. We have 3 hydrogens. We have nitrogen. Then we have 3 more hydrogens. Really the only place to put them. Okay, let's count how many electrons we used in drawing our bare bone structure. 2, 4, 6, 8, 10, 12, 14. Ooh, we used all 14. We don't have any left. But if we look, everything has a full octet. So all we have to do, add our brackets and our charge. See, aren't these a lot easier than the non-charged ones? Let's try H3O plus 1. This is called hydronium. So the 3 hydrogens have 3 valence electrons. Oxygen has 6. It has a charge of plus 1, which means we're going to subtract 1, which means that we have 8 electrons to work with. So hydrogen can't go in the middle because it only forms 1 bond. So we must want oxygen in the middle, bonded to 3 hydrogens. So we just drew 1, 2, 3 bonds, 2 electrons in each of the bonds, which means we used 6. So we have 2 electrons left, which is perfect because you can see that oxygen just needs those 2 in order to have its full octet. And we'll finish it off by putting brackets and the charge as a superscript. These have been really simple so far. So let's try the most challenging one. NO2 negative 1. If you look at your polyatomic ions, this one is called nitrite. Nitrogen has 5 valence electrons. Oxygen has 6, but we have 2 of them, so that would be 12. And it has a charge of negative 1, which means we're adding 1. So 5 plus 12 is 17, plus 1 is 18. Okay. I'm going to put nitrogen in the middle because it's written first. And I'm going to draw an oxygen on either side. Be symmetric when we can. In drawing those 2 bonds, I just used 4 electrons, so I have 14 electrons left. But if I look, I still need 2, 4, 6, 8, 10, 12, 14, 16. So what I want to do, because I only have 14 electrons, is I need to add a double bond. So if I add a double bond here, I used 2 more electrons, so I have 12 electrons left. And if I look, I need 2, 4, 6, 8, 10, 12. So that means I am all done. I have enough. I can go in, add my lone pairs. I used my last 12. I don't have anything left, but that's okay because everything has an octet. And step number 4, finish off this Lewis structure by doing brackets and the charge. And that is the end of our notes today. So good luck on your worksheet.